'Tis the season for my truck to be stuffed full of empty boxes and no time to do anything about it. But this morning we have a gentleman gave us a call, said his main floor system did not appear to be working. I believe it was about this time last year. I stopped by and he was having an issue with his master bedroom, and it ended up being a dual capacitor on the outside that was faulty. This time around, he seems to believe it's probably a dual capacitor as well for the main floor. However, he also mentioned that he went up to change the filter to double check, and it did not seem like the system was working up in the attic, and that he really hasn't noticed any airflow through the ventilation system. So that really strikes me as it's probably not a dual capacitor. Your capacitors on the outside, they don't really have anything to do with the indoor units as far as the systems are concerned, unless it is a communicating system. They really have no idea the other one exists. They just do what the thermostat tells them to do, essentially, and don't really care if there's another unit attached. So this strikes me as he's likely got more of an issue with that upstairs system. It could be high voltage issue, maybe low voltage issue where we have a short somewhere. On the other hand, if it's a blower motor or something going out, it could possibly cause that outdoor system to hit low pressure and shut itself off. Who really knows? But we'll stop by and take a look, see if we can figure it out for him, and probably add another empty box to my collection. But we'll see what we find. So the thermostat is set to operate and cooling. I do hear and feel the transformer buzzing. Outdoor unit's not operating, but there is water coming off the coil. So that tells me it has been operating. And our LED is not displaying any kind of error. It's just showing continuous run. And right now we did just hear the compressor come back on outside. So what's likely going on is it's running until the low pressure switch gets low enough, shuts itself down, and then essentially just waits on the short cycle timer until it starts back up enough once the pressure rises after it shuts down. So we likely have an issue with our blower motor here. Let's take a look. We do appear to be an electronically commutated motor. So in this particular case, there's no capacitor to look at, since it's essentially a DC motor with a controller module. So first thing we'll probably look at is just be sure we actually have high voltage power when we turn the power back on. So our neutral lead is here and our 120 volt is here. Just want to be able to press the button, or the interlock switch rather, while I'm testing. We'll just hook up to our neutral lead area here, place this here just to be sure we have 120 volts, which we do, so we know it has main power. And our next step, this particular one, it's 120 volts for power, but our control is all low voltage. So we have various speeds, with this one being our common. So our next step is to do a similar process where we will just see if we have low voltage power going to once it tries to energize. And if we do, then we know we have a faulty control module on the blower. We do have 24 volts being supplied to the motor as well, 26.6. So in this particular case, provided our control module on the motor itself is good, it should be operating. There was a time where they actually wanted you to troubleshoot it, pull the module off, see if the motor itself was good. In all honesty, DC motor, they don't really go bad that often. It's typically the control head, and there for a while you could actually purchase the control module separately. Nowadays they don't really do that very often. We will try, but depending on the cost of this motor, being that this is a carrier unit, it's probably fairly prohibitive, and we could probably get a general replacement motor that will do all the same thing for much cheaper. So we will talk to the gentleman and see which direction he might want to go with it. We've made it back. Being this guy is a carrier and it is out of warranty, the OEM blower motor was obscenely pricey, so instead they opted to go with one of these Evergreen ECM motors, and they're basically just a general replacement guy, easy enough to install. Literally does the same thing RPM horsepower wise, so we'll get him installed. This motor can be either 240 volt or 115 volt. So it comes, my wick's dying. It comes with a little jumper here. You have one for 230 volt operation. And you have another jumper for 115 volt operation. And the 240 volt is just basically plastic. It comes set up for 230, 240 volt. The 115 is actually a little jumper. But if we follow our motor around, we have the little spot for it to fit right there. Just fits into those little prongs. So if you do end up with one of these aftermarket motors, be sure to do that, because it can cause yourself lots of problems. It's easy enough here as well. You have your common for your low voltage, line, ground, and neutral. Then you have your speed taps, and generously give us a little wiring harness with some clips to fit in. There's two little rails in there that it just has to slide in. There we go. So we'll just go one for one with our low voltage connections here and hook this guy up to high voltage. So they do try to differentiate for us. So our high voltage connection uses these much smaller little spade clips. Those are the standard sizes they're using for all the low voltage. That way it makes it very hard to mix your low voltage and high voltage just due to the size difference of our little spade clips there. Add these in and reattach main power. As far as your speed taps go, they gave you a handy little diagram so you can tell what color and what number corresponds to what speed or static pressure reading, but it's also on our wires, so easy enough to tell. So first we have heat. We will probably put that on, I'd say medium high. Cool, we will go with high speed, which is yellow. For just continuous fan operation. And the rest of those can go on spare. Alright, everything's all hooked up. Back in place, we just have a jumper going from red to yellow so that we can try to do this somewhat easily. So we'll turn our power back on. Push our switch. Look, you can kind of see that fan motor spinning one way. And it's going to slow down momentarily. Then it will start rotating the opposite direction, and the little controller on the motor is going to decide which way was the correct direction based on the amount of amperage. And it did not take it long to say, yep, that's the direction. Then it should start up for real. So after it finally decides which direction to spin, it starts up in high speed as it's being told to for running and cooling operations. And I do hear a refrigerant running through the line set, so we should be good to go. The only bad part is I have to take my finger off that interlock switch to put the door back up, so that will shut it back down and make it go back into a delay. Unfortunately for that particular customer, it did not end up being the capacitor. It was that constant torque or ECM blower motor in the furnace up there having some issues. That particular motor, I did price it through Carrier. However, they wanted a fairly exorbitant amount of money for it. We were able to get a Gentech general replacement motor. I believe it was under the Evergreen line. That motor, with installation, all the labor we had to do for it, we ended up being less than half of what they wanted to charge us just for that Carrier motor. So customer much more happy. As far as operation, everything's just the same, literally hooks up just the same way. One thing to watch out for those ECM motors, the general replacements, they are general replacements, so they have the ability to run as either 230 volt or 115 volts. So you do have to pay attention to your application, read your instruction, make sure to either put in a pin or not put in a pin to have it operate at whatever voltage. Other thing to remember, those motors are actually very easy to install, in a lot of ways easier than the permanent split capacitor motors. Essentially though, you have all your low voltage and high voltage on the same module on that motor. The upper run there, as you saw, it had the high voltage connections, the line, neutral, and ground, and then you had the 24 volt common. That lower run with the numbered settings on it, that was actually your speed tap settings, and that's all 24 volt low voltage as well. So interesting little motors. Honestly, a lot of times application wise, you'll run up into a lot of air handlers that don't even have relays or anything anymore. They're just running directly off the low voltage from the thermostat, turning things on and off. So pretty cool little motors, but I like the Gentech Evergreens. But we'll move on to the next one, see what we can find, and hopefully get into some more trouble.